Hey everyone, and welcome to this explainer. Today, we are looking at an absolutely massive paradigm shift in modern software engineering. We're basing this off Google's May 2026 white paper, titled Vibe Coding Agent Security and Evaluation. So, look, we're rapidly moving away from the days of meticulously writing deterministic syntax-heavy code line by line. Instead, we're entering this wild new era of vibe coding. This is where developers literally just describe what they want in plain English, and autonomous agents build it on the fly. It's incredibly fast, a real game changer, but as we're about to see, it requires an entirely new playbook to keep our system secure and our code actually functional. Okay, let's dive into this. Vibe coding is all about expressing your intent in natural language and basically trusting an intelligent system to do the heavy lifting of translating that intent into working software. Sounds like magic, right? Well, here's the catch. A raw AI model is not an agent. It actually only becomes one when it interacts with your environment. Left to its own devices, a raw AI model possesses a very dangerous quality called ambient agency, which is essentially the ability to act autonomously within a system. Until you've got that ambient agency properly secured in a harness, it poses a massive risk to your enterprise.
To really understand why this is so risky, we have to look at how the whole concept of trust is changing. In traditional, deterministic software, trust is completely binary. Your code compiles, or it doesn't. Your static credentials are valid, or they aren't. Your syntax is totally predictable. But when we move into agentic systems, everything is non-deterministic. You've got an autonomous workforce, writing code, pinging APIs, and dynamically changing environments. Because of this, static identity is practically useless. Trust can no longer be a simple one-time gate. It has to evolve into continuous effective trust, meaning it's continuously earned and verified throughout the agent's entire workflow.
So here's our roadmap for today's explainer. We'll start with the vibe coding revolution, then we'll build the walls with the agent security harness and Agentic SecOps. After that, we'll look inside the glass box by exploring the under-specification gap, and finally, evaluating agent quality. Section 1. The vibe coding revolution, moving from syntax to intent. High-velocity, intent-driven development is absolutely incredible for innovation, but it completely shatters traditional security perimeters. We aren't just securing web apps anymore. We're tasked with securing a non-human workforce. Which brings us to Section 2, the Agent Security Harness, and shifting to context as a perimeter.
Because our old static identity perimeters just do not work for non-deterministic AI, we have to build a strict external safety envelope around it. That envelope is built on these 7 pillars of agent security. We've got infrastructure and networking to isolate execution, data to protect those sensitive context windows, the model itself, securing system prompts from semantic attacks, application and runtime, which features LLM firewalls, identity and access management to verify exactly who is interacting with the system, observability and COps, so we can monitor the agent's invisible internal reasoning, and finally, governance, ensuring all autonomous decisions meet your regulatory standards. This whole shebang forms the foundational safety harness you absolutely need to host an autonomous agent safely.
Now, let's drill down into a couple of those pillars, specifically looking at how we secure the execution environment. Vibe-coded agents work in this high-speed, iterative loop. They write code, run it, read the errors, and try again. This logic has to run in ephemeral, kernel-level, network-isolated sandboxes, like vSort. Why? Well, because of a massive supply chain vulnerability. Attackers know that AI models hallucinate fake software packages. So what do? They publish real malware under those fake hallucinated names. It's a tactic known as slop squatting. If your agent isn't totally isolated, it might just download a typo-squatted virus right into your host node while it's just trying to solve a coding problem. We also have to manage identity, specifically dealing with something called the confused deputy problem. That's where an overprivileged agent gets tricked by a malicious prompt into doing something highly dangerous. The solution here is Zero Ambient Authority. Agents get fresh, hyper-restricted credentials just in time, and they expire immediately. And for really high-stakes actions, we use what's called the vibe diff. First, the agent requests the action. Second, an evaluator translates that dense generated code back into a plain English summary. Finally, a human developer actually reads that summary and gives explicit cryptographic MFA approval. This completely stops developers from blindly approving generated code that they don't even understand. Moving on to Section 3, Agentic Security Operations, which is all about automated defenses for high-velocity execution. And this brilliantly illustrates how we handle SecOps now. Manual human security reviews simply cannot keep pace with vibe coding. Our defenses need to be just as autonomous as the agents themselves. So we deploy an automated SecOps triad. You've got the red team acting as the agent attacker, dynamically injecting adversarial vibes and jailbreaks into context windows to pressure test your system. Then the blue team is your agent defender, using behavioral analytics to monitor the runtime agent bill of materials, or AG bomb. If the agent starts pulling weird, unapproved tools, the blue team flags it instantly. Finally, the green team is the agent fixer. If an anomaly pops up, it executes a stateful quarantine to freeze the agent, and then autonomously rewrites the insecure script to patch the vulnerability on the fly. So picture this. Our agent is securely locked in a sandbox, governed by Zero Ambient Authority, and carefully monitored by an automated SecOps triad. It passed every single security check. But here is the critical pivot. A perfectly secure agent can still fundamentally misread your intent, totally ignore project conventions, and just write terrible code. Security tells you it stayed safely inside the boundary. It does not tell you if the output is actually worth shipping.
Which takes us to Section 4, the under-specification gap, and dealing with missing specs.
We are crossing over from security to evaluation here. And let me tell you, it's drastically different from traditional testing. Traditional testing assumes you have a complete, rigid specification written out before coding even begins. But natural language prompts, they're inherently fuzzy. Telling an AI to make the dashboard load faster is definitely not a rigid test case. This right here is the under-specification gap. The foundation model has to rely on its own latent aesthetic judgment to fill in your missing blanks. And since you, as a user, can't instantly read and validate 600 lines of generated code, we need entirely new ways to figure out if the agent actually built what we meant, not just what we literally said.
And that brings us to Section 5, evaluating agent quality, measuring the inside of the glass box.
Think of it this way. If security is the thick concrete wall around the system, evaluation is how we systematically measure the inside of the glass box. We need to measure the quality, efficiency, and alignment of an agent's internal reasoning over a whole multi-turn session. To tackle this, the white paper lays out 7 distinct evaluation dimensions. We have the user-facing metrics: intent satisfaction, did it actually build what you wanted? Functional correctness, does the code compile? Visual and behavioral correctness, does the app look right on the screen? And cost and efficiency, how many tokens did it burn to get there? Then we've got the internal metrics that the user never sees: code quality, trajectory quality, did it read the right files and pick the correct tools? And lastly, self-repair behavior. When a build fails, does the agent actually fix the broken code, or does it just lazily delete the failing test? Because we're looking at so many different dimensions here, no single testing method is going to cover everything. For production pipelines, you have to combine multiple approaches. You need your standard automated testing for functional correctness, security scans to catch the vulnerabilities, LLM as a judge frameworks to score the fuzzy things like intent and code style, browser testing to see if the UI is actually usable, and trajectory inspection to analyze the agent's step-by-step internal reasoning. You really have to use all of these in concert to get the full picture. Now, here's an incredibly practical tip straight from the white paper on how to handle failure. In vibe coding, a session is almost never perfect on turn 1. Every single time a developer types, "No, not like that," they are handing you labeled failure data. The trick here is to evaluate multi-turn session convergence rather than just turn-level accuracy. You group those user corrections together to spot systemic gaps in what the agent can do. A truly successful session is one that converges on the right answer quickly, not necessarily one that nails it perfectly on the very first try. So the crucial point is this: you simply cannot secure or evaluate what you cannot see. Observability is the absolute prerequisite for everything we've talked about today. You have to track the entire vibe trajectory using frameworks like OpenTelemetry. You literally need to log the exact cognitive leap from the user's initial prompt all the way through to the tool calls and the final code generation. If you don't trace that trajectory, agent failures are just going to look like inexplicable, monolithic crashes, and you won't know how to fix them. Before we wrap up, I want to leave you with this really powerful concluding thought from the white paper. To quote it directly, generation is largely a solved problem. Verification, security, and architectural judgment are the new craft. End quote. We are no longer waiting on human hands to type out boilerplate code. We are waiting on human minds to define the boundaries, evaluate the outputs, and secure the execution environment. That is exactly what the modern software engineering craft looks like in the vibe coding era. Which brings us to our final question for you to mull over today. Are your enterprise agents securely harnessed within the 7-pillar architecture, or are they just ambiently dangerous right now? Take a close look at your own workflows. Are you actually evaluating intent, or are you just checking if the code compiles? Thank you so much for joining me on this explainer. Keep learning, keep structuring your systems, and I'll see you in the next one.